Cassette number 4, program 10-1A. Slide number 141. The next item out from our machine is this collar. If you're using an 11-inch platen machine, you do not have the collar which is shown here. All 13-inch or 17-inch machines, however, do have this collar. The function of this collar is that of preventing the operational shaft from moving towards the right. On 11-inch machines, this function is performed by the operational cam assembly, which is mounted on the operational shaft directly against the right bearing of the shaft. The same is true for the collar shown here. It prevents the operational shaft from working itself out towards the right, and it is mounted directly against the left side of the operational shaft bearing. Slide number 142. To prevent the operational shaft from working itself towards the left, we utilize the shift arbor against the hub of the shift cam or bearing. In summary, then, we can say that the operational shaft bearing is responsible for holding the lateral position of the operational shaft. Slide number 143. Now, locate the left side bearing collar for the operational shaft. It fits inside of this hub. During servicing, whenever we have to remove the operational shaft, we should check the amount of play which exists between the operational shaft and the bearing collar, or between the bearing collar and the drive or hub pulley assembly. More often than not, we need to replace the bearing collar. Notice these lugs on the drive or hub pulley assembly. Slide number 144. The lugs on the drive or hub pulley assembly fit into these openings of the torque limiter hub. On the standalone or office products electric typewriter, the torque limiter hub is made of synthetic material, which has the advantage of reducing the noise during the operation of the machine. Slide number 145. On older machines, or on input-output models, you will find metal torque limiter hubs. Metallic torque limiter hubs will come equipped with nylon inserts for the purpose of noise reduction. In time, these inserts wear and need occasional replacement. This is the torque limiter of an older office products typewriter. Slide number 146. As you found out during the disassembly of the operational shaft, the torque limiter hub is anchored directly onto the operational shaft, thus becoming an integral part of the operational shaft when the machine is fully assembled. Let us now take a closer look at the so-called torque limiter assembly. Slide number 147. The torque limiter assembly is made up of two clutches, the carry return clutch on the right and the torque limiter clutch proper on the left. You have probably noticed by now that the carry return pinion gear fits quite loosely inside the carry return clutch spring. This amounts to saying that this clutch spring must be made to collapse or to tighten up onto the arbor of the carry return pinion gear. Notice that on the left side, the carry return clutch spring is held in place by a clamp, which fits over the spring, holding it to the carry return driving arbor. This takes care of holding one end of the clutch spring. During carry return operations, the other end is held by the carry return shoe, as we will examine when we study the carry return mechanism. carrier return clutch, by the way, is another clutch which should be kept free of lubricants. Because of the fact that any lubricant placed anywhere on this assembly would eventually work its way to the spring clutch, we simply leave the whole assembly dry or free of grease at all times. The large friction spring on the left is the torque limiter clutch spring, or simply the torque limiter spring. Slide number 148. This torque limiter clutch spring is the only part which holds the indicated carrier return driving arbor to the torque limiter hub. The job of the torque limiter spring is to control or limit the amount of twisting force or torque that can be transmitted from the torque limiter hub to the carrier return clutch driving arbor. Slide number 149. The exact amount of torque delivered by this clutch is determined by the spring tension developed between these two anchor spots for the torque limiter clutch spring. Slide number 150. Be very careful not to mar the surface of the carrier return driving arbor with pliers when you perform this experiment. If you hold the carrier return clutch driving arbor with pliers in a stationary condition, you can turn the torque limiter hub top to the front, and thus feel the amount of torque delivered by the torque limiter hub. Slide number 151. The left end of the torque limiter spring is held by the metal bracket at the point indicated by the yellow pencil. For coarse adjustments of the carrier return clutch torque, we can change the position of the bracket by first loosening the screw indicated by the green pencil. Slide number 152. For fine adjustments of the carrier return clutch torque, we use the indicated eccentric stud. Notice that it too is mounted on the torque limiter hub. You will find that on later machines this stud no longer exists. Instead, we simply use various spring anchoring points on the bracket, which is used to hold the left and the right end of the torque limiter spring. Slide number 153. In conclusion, let us say that the torque is adjusted by the tension of the spring indicated by the green pencil. If we should reach the maximum adjustment for the stud which holds the spring, then we must go to the coarse adjustment of the torque limiter hub. We would thereby change the angular position of the torque limiter spring. We mentioned earlier that the carrier return clutch spring must be made to collapse. We accomplish this by applying a dragging pressure to 2 or 3 of the rightmost coils of the carrier return clutch spring. To fully understand this, it is necessary to consider that the carrier return spring is constantly turning with the torque limiter hub, while the carrier return pinion gear is stationary. Slide number 154. The dragging effect upon the carrier return clutch spring is generated by this carrier return shoe. When this shoe presses against these outer coils, the friction developed between the rotating spring and the stationary carrier return pinion gear causes the diameter of the spring to become smaller until the spring develops a firm grip onto the arbor of the carrier return pinion gear, and until eventually the gear is forced to turn with the spring. The engagement of the carrier return shoe with the carrier return spring is caused by the carrier return engagement cam, which we studied a bit earlier. As we mentioned earlier, the mechanism which takes care of accomplishing this engagement is covered in our training package number 2-5 on the IBM Selectric typewriter. Slide number 155. The turning of the gear top to the front, red pencil, will cause the tabulation cord drum to turn top to the right. This rotation of the tabulation drum gear will feed out the tabulation cord, which is attached to the left side of the carrier. Slide number 156. As you follow the escapement shaft to the rear, you find that the carrier return cord drum, red pencil, will also turn top to the right, but it will tend to pull in the carrier return cord. The carrier return cord extends out of the left side of the carrier. When we pull on it at the same time as we feed out the tabulation cord, the end result is carrier movement from right to left, or simply a carrier return operation. Slide number 157. Now it is time to reassemble the operational shaft. We shall first install all the components onto the shaft without tightening them down. As you install the torque limiter, be sure to place the carrier return pinion gear into proper engagement with the tabulation cord drum gear. It is very easy to end up with a pinion gear to the right of the drum gear teeth.